In actual practice, for copper system, most soldering is done at temperatures from about 350 degrees to 600 degrees, while most bracing is done at temperatures ranging from 1100 to 1500 degrees. Brace joints are used where greater joint strength is required or where system temperature are as high as 350 degrees. Applications for bracing includes water supply and fuel gas distribution, medical gas, air conditioning and refrigeration, and fire protection. Today we'll be talking about bracing copper tube. First, assemble the joint by inserting the tube into the socket against the stop and turn it if possible. The assembly should be firmly supported so that it will remain in alignment during the bracing operation. Apply heat to the parts to be joined, preferably with an oxy-fuel torch with a neutral flame. Air to fuel sometimes used on smaller sizes. Heat the tube first, beginning about 1 inch from the edge of the fitting, sweeping the flame around the tube in short strokes at right angle to the axis of the tube. It's very important that the flame be kept in motion and not remain on any one point long enough to damage the tube. Bracing flux may be used as a guide to let you know how long to heat the tube. Switch the flame to the fitting and the base of the cup. Heat uniformly, sweeping the flame alternately from the fitting to the tube until the flux becomes quiet. Avoid excessive heating of cast fittings due to the possibility of cracking. When the flux appears liquid and transparent, start sweeping the flame back and forth along the axis of the joint to maintain heat on the parts to be joined, especially towards the base of the cup of the fitting. The flame must be kept moving to avoid melting the tube and the fitting. For 1 inch tube and larger, it may be difficult to bring the whole joint up to temperature at one time. A mild preheating of the entire fitting is recommended for larger sizes, and the use of a second torch to remain a uniform preheating of the entire fitting assembly may be necessary in larger diameters. Apply the filler metal at the point where the tube enters the socket of the fitting. When the proper temperature is reached, the filler metal will flow readily into the space between the tube and the fitting socket. Draw in by capillary action. Keep the flame away from the filler metal itself as it is to be fed into the joint. The temperature of the tube and fitting at the joint should be high enough to melt the filler metal. Keep both the fitting and the tube heated by moving the flame back and forth from one to the other as the filler metal is drawn into the joint. To aid in the development of this fillet during bracing, the flame should be slightly ahead of the point of filler metal application. Stop feeding as soon as you see a complete fillet. When bracing horizontal joint, it is preferable to first apply the filler metal slightly off-center at the bottom of the joint, proceeding across the bottom of the joint and continuing up the side to the top of the joint. Then return to the beginning point, overlapping slightly, and proceed up the uncompleted side to the top, again overlapping slightly. On vertical joints, it doesn't matter where you start. If the opening of the socket is pointing down, care should be taken to avoid overheating the tube, as this may cause the bracing filler metal to run down the outside of the tube. After the brace joint has cooled, the flux residue should be removed with a brush, clean cloth, and warm water. All fittings should be allowed to cool naturally before wetting. Some installations, such as medical gas and ACR system, require the addition of an inert gas during the bracing process. The purge gas displaces oxygen from the interior of the system while it's being subject to the high temperature of bracing. Therefore, eliminates the possibility of oxide formation on the interior tube surface.